Hello guys. Okay, so welcome back to our Android tutorials, and today we are going to focus on RxJava, and it is all about reactiveness. Guys, today the paradigm is going to change a bit. There's a blog I've already written on RxJava on Medium. Okay, so right now what I'm coming to do is we are not going to do a lot of coding today, but we are coming to have a talk on the understanding RxJava, the basis and the concept of RxJava. Then on our subsequent videos, we decide to have a practical session on the various RxJava, the operators we use in RxJava. Then we can continue. So today I have a blog already on understanding RxJava. When you go to Medium and you search for Nyamebe Smack, you will see these tutorials. I have a lot of tutorials, okay, like a lot of blogs on Android on Medium platform. So you can visit here on my channel, then you will have all this to read. So let's get it started. So in this article or these tutorials, we have this RxJava explained. And what is RxJava? So RxJava is all about reactiveness, okay? How in your development your data can react to some event or something that you have, or maybe some of the notifications, SMS, a lot that you want to listen to. So you can employ RxJava in those implementation. So RxJava, as I said, when it comes to reactiveness, reactive extension is deployed in so many programming languages. We have Java, Kotlin, we have Ruby, we have PHP. If you go to this site, okay, if you go to this site, you have a lot. Like this is the documentation. Then you can select the language that you are comfortable with. Is it ours, JavaScript, .NET, Scala, Clojure, Swift, and a lot more here. So my site is just a brief description, and it's more specific on RxJava. And what is reactive X? So it is just a pattern that is following observable pattern, okay? And if you want to have more looks on observable pattern, I think you can read more on Wikipedia so that you can have like a broadened mindset on observer pattern. When we talk about observer pattern, what does it do? Okay, how helpful it is in our development. Okay, so we talk about that. So it actually makes use of observable pattern to support sequence of data events and add operators that allow you to compose sequence together while abstracting away concerns like low-level threading and synchronization, thread safety, and concurrent data structures. Okay, so this what it's trying to do. So what it's trying to say is, making use of reactiveness or reactive X, that's specifically RxJava, you don't need to specifically, try to create your own thread. If you want to maybe do something in the background, creating your own thread, which is sometimes, if you are not really experienced, you might miss some part of it, and at the end, though you are doing the work in the background, but then it is causing more harm than good. So using just a piece of code in RxJava can do this threading, synchronization, and it will even achieve thread safety. Like when you talk about thread safety, you can have your implementation in one thread and expect that implementation to be on a different thread. Let's say thread A and thread B. So thread A implementation, and you expect like the communication will be there. The synchronization between different threads. So, and that's all that is about thread safety. So in this block, we are not going to read everything, okay? So if you want to have more understanding, you can come to this block and have a reading of it, a read of this block. So what is observable pattern? This block talks about observable pattern. And when you talk about observer pattern, uh two major let me see components come together to form observer pattern. Now, to have a pattern like observer pattern, you should have a subject and you should have observer. So the subject is just like a bit, it's just like the object or the data that we are listening to, that you are keeping track of. That will be the subject, and the observers are those, let me see police listening to those. If it's a food, like the subject will be the food and the observer will be the ones eating the food. Okay, so the observer notifies automatically of any changes, usually by calling one of this method. Okay, yeah, so the observers actually get notified when there's any change in any of the states that we have mentioned. So there's a brief description here, a diagrammatical description of the observer pattern. Okay, and then the subject, and this is the observer. So observer is actually listening to this subject. Okay, so I think we can come here and we have more understanding. This is actually beyond the scope of what we have to talk about today, so we are not going to dive more into this. So let's quickly talk about the building blocks of RxJava. Okay, so what are the building blocks of RxJava? We have two basic building blocks of RxJava, and we have observable, then we have subscribers. So as I said, so this represents the source of the data, the observables, the source of the data, and they mostly emit data to the subscribers or the observers, those listening to them. The listeners in RxJava, we term them as observers or subscribers. Okay, and on these subscribers, they have when it comes to subscribers, these are the observers. Observable can have more than one observers or subscribers. Okay, and we have this method. We have this method we mostly have this method, the on next, on complete, and on error. So when, let's say, the subscriber is listening to the observable, okay, we have, let's say, a list of them, a list of data, and the subscriber is listening to them. So it will be emitting, the observable will be emitting this data in a sequence, one by one, sometimes. Okay, not all the time, sometimes. So whenever a data is emitted, it is being triggered in subscriber on the on next. Okay, the on next will be called, and when everything has come to complete, then on complete method will be triggered. Then whenever there's an error, then an error will be triggered. Okay, so as I said, so there are four types of observables. We can categorize them into observables, flowable. Then again, we can also talk about single, and lastly, we talk about maybe and completable. Okay, so these are the basic categories of observables. Observables. Okay, so when you say observables, these are the data that emit from 0 to the infinity number of items. Okay, 0 to n number of items, and terminate with either success and a success or an error. So, and in this blog, I think you can read about this. We have example when we are trying to download maybe a data from internet, and let's say the file has been downloaded already. So like it's getting downloaded. So we could use observables, okay, to emit the values, maybe to keep track of the sequence, the process. So if you know the interval, we can use maybe a progress bar, and with the help of the RxJava, it will be emitting the intervals for you, maybe at every second, or how many how many bytes of data is being downloaded per a second. So all these can be calculated, and you can get it calculated through the observables or the RxJava, and you can have your way with the implementation. Then we have Throwable. The Throwable is more or less like the observable, but the difference is that with the Throwable, it is able to withstand a lot of pressure. Okay, so for example, if you have, let's say, a billion or a million, millions or billions of data being that we are listening to, for example, if you are using observable, sometimes it can lead to overflow. Because the buffer size is by default set to 128 elements, it will lead to overflow. But with the Throwable, we have some strategies that we can adopt, like back pressure strategy. Within the back pressure strategy, we can specify whether we want a drop, a buffer, latest, error, missing, and etc. Okay, so with this we can make use of this implementation or strategy. So what the drop actually talks about is this tend to discard the unnecessary items when it exceeds the buffer size limit. Okay, when it exceeds the buffer size limit. Okay, so with the drop, so as I said, this strategy tends to discard the unnecessary items when it exceeds the buffer size limit. So, but one thing in using the Throwable is that I think it has the buffer size is more than the one for the observable. Okay, so if you use a drop strategy, when the items emitting, the emitted items is more than the size of the buffer, okay, it will discard all the unnecessary, it will discard the other ones once it has exceeds the buffer size limit. And with the buffer, what it does is that this buffers all the emitted item from the producer and watches out for out of memory exception. Okay, so when it is emitting, instead of emitting 1 to 10, it will, let's say, emit from 1 to, let's say, 100 of items. Why it is not a really emitting, it will try to contain 1 to 100 items, and in the process, and still watch out for any out of memory exception. When there's maybe memory exception, then it will emit up to that number where the memory exception occurred. It will emit to you. So that's how the buffer strategy works. The latest, so it keeps the most recent ones. When we are using latest strategy, it keeps the most recent ones. As I said, the name describes itself. The error, this throws error in case of over emission, and with the missing strategy, it will throw a missing back pressure exception sooner or later somewhere on the downstream. So this is just a diagrammatical representation of how the Throwable observable works. Then we can also talk about, and all these diagrams is by the kind courtesy of ReactiveX. You can go there and you see everything here if you start to read their APIs documentation. And we can also talk about single. Single is also a type of observable, but here's the case. This is used when the observable needs to emit only a single successful value or an error, and we do not need incomplete as it is for Throwable and observable. We can use this for network calls when we normally get single requests at a time. So this is one of the usages of a single. So with single, we mostly expect one result. Okay, we only expect one emission, and here it doesn't call incomplete as it does for observable and Throwable. with single incomplete doesn't trigger. This method hook doesn't trigger. And this is also a diagrammatic representation of the structure of single observable. Then we can also talk about maybe. What is maybe? So maybe is mostly like the single, but here is the case: the single, when you use single, you are 100% sure that you are going to get an emission. If maybe the scenario or the situation that you are encountering, you are not sure of whether there will be an emission or there won't be any emission, you are better off to use maybe. And this, in this case, as it says, it is used when the observable has to emit an item or no item. So it is either when you are using maybe, you get an item or you do not get an item. So this also the diagrammatic flow on it. And completable. Completable is one of the unique ones. It does the job. So actually it does the job, but you don't get any emission. So if you have a scenario where you want to do the job, but at the end you do not get emission to the subscriber or the observer, then completable observable should be your go-to. And this is a diagrammatic representation of it. Okay, so here, if you want to implement all this in your Android Studio, the Gradle file, you can implement this the Gradle dependency. You are okay, and you are good to go. Then you sync it and you'll be having all this. So basically, this is the concept on RxJava. And as we said, so a brief description, we can talk, we have the observable, the subscriber, and different types of observable. We have talked about single, throwable, completable, maybe. Okay, all these we have talked about. So now let's try to know how to create observable. Okay, so right now ReactiveX has made creating an observable very easy step. Very easy step. And observable can be created out of everything. In fact, anything can be an observable. So if you have something which is an observable, we can create it, basically create it through the create method. And I have maybe a coding like I have already given an example on how to use the create on observable. All that you have to do is you call the observable.create and you put in the items. So this is where the items that you want to create are observables. So to be put in the subscribe function within the observable on subscribe class. So after the observable has been created, then it is up to the subscriber to subscribe to the observable. Okay, and here it means subscribe. So as I said, so for observable, you have the onNext. So onNext method hook is what brings the emission. Whenever there's an emission from the observable will listen to this or get those emission from this method. And when there's any error, it will be returned in this method block. And when it has been completed, we get the completion, everything in here. And these method hooks are very helpful, very helpful. Okay, very helpful. And I think we also have some of the various ways of creating observable. So we have demonstrated with the create. Then we can also use just. So the just will just help us to it is just a wrapper around any other data types. Okay, so we can have, now we can, with the just, we can convert a string to an observable, we can convert integer to observable, we can convert, in fact, any data type to observable. So if you want anything like that, you can use just. And from a Throwable, this is more or less of data structure, and it is relating to the arrays or the list. I mean collection APIs. If you want to convert your collection APIs to observable, then we are better off using the from a Throwable. And we can also talk about from array. So this, and they are self-explanatory. This is converting an array to observable. From callable, if you have a callable and want to convert a callable to observable, you can use it from callable. And we have from future, interval. Okay, so the interval is basically has to do with time. Okay, time. And mostly if you specify your interval, let's say if you want to do your work every 2 seconds, mostly it is 1 second. So if you want to do your work every 1 second, you can use interval. So with the interval, it will make sure it converts the seconds emission to observable. So every second, in every second, then you see like you are going to get emission. So mostly we will talk about this in our subsequent tutorials on how to use all this interval there. From everything, we will just have a coding session on all these, then we will learn how best we can use this. Then also we can also talk about range. The range is converting like a range of number, okay, into observable. So you can have a range, let's say a range from 1 to 10. So it will start emitting 1, 2, 3 up to 10. And these are all observables that we can use in your programming. Then also we have something called, and all these methods are also available on other categories. On other categories like throwable, maybe single, or that we talk about. You can have all these methods. The from future, from callable, all these can also be available on other categories like the throwable, maybe, and single, as we talk about. Then we can also talk about disposable. Mostly what happens is we have to, after all this work, we have to garbage collect them. Okay, we have to garbage collect them so that it doesn't consume a lot of memory. So the disposable is what we mostly use to contain. Okay, we mostly use to contain all our work. Then when, let's say, the activity or the fragment is being completed or destroyed, we can dispose of the, maybe all the memory that it has consumed. It will be freed up. So observable do not listen to the observable externally, and this means when we do not need observable to listen anymore, we need to detach them from their subscribers. Okay, you have to detach them from the subscribers, their subscriptions. After subscription, we could get them in a form of disposable. So as the term disposable, we are going to dispose them like a rubbish. We are disposing them. Then we can also use, this is if you are using a disposable, it's for just a single collection. But if you want to have a multiple disposable or collection, we can make use of composite disposable class. And this is to store all the disposable after subscription. Then it will just dispose them for you with just a single call. So this is just a brief description on how to use the disposable. Okay, now after the work, it's mostly return disposable. Then we can add it to our composite disposable, and then we can call dispose to dispose of everything that we had. So this is just a conclusion on it. So guys, today our section, basically I wanted us to have like the understanding, the concept behind reactivex. Okay, and in that way it has become much easier when we start with the coding. So now we have learned about, in summary, we have learned about how helpful RxJava or the reactivex is in our coding implementation. And actually, as I said, reactivex is just following observable pattern, an observer pattern. Okay, an observer pattern, and you can read about it. And here we talk also about the building blocks of RxJava. That is the observable and subscriber. Okay, and we talk about that. And then again we went ahead to talk about the categories of these observables. We have observable itself, we have the throwable, we have the maybe, we have the single and the completable. And in the throwable, we describe the difference between the throwable and the observable. One of the major and important difference between the throwable and the observable is the back pressure strategy, which is being used in throwable, but in observable we don't have such. So that's one of the major difference in the throwable and observable. We can talk about them. Then we went ahead to know how to create observable out of non-observable data. Okay, and we talk about using create, we talk about using just, from iterable, from array, from callable, from future, using interval, range, all this. And finally we talk about the disposable. After the work is being done, or after the subscription, so when the subscriber is subscribed to an observable, after the day's work, or after the work is being done, we have to unsubscribe. Okay, and this unsubscription is gotten from the disposable. So whenever we try to dispose them, it's like we are unsubscribing to what we have subscribed, and in the long way we are freeing up the memory, because we need memory to keep track of what we are observing. So at the end of the day's work, for us to have efficient application, we have to unsubscribe. So we do that by using the disposable, so that you don't have out of memory exception, as is rampant in most of the application. So this is basically what we wanted to talk about, and you can get all this in on my blog. Okay, Medium blog, understanding RxJava. So guys, this is the end of today's tutorials on RxJava, and the next time we dive more into the coding pattern. Then again, we also talk about the operators that we use in RxJava. Thank you very much, and don't forget to subscribe to this YouTube channel if you haven't, so that you can get the most out of what we have. Thank you guys, and have a good coding time.